I'm Abhi.
And today we're going to indirectly measure the top of this tree.
Okay, so this is the diagram that we have, okay? So this is Noelle right here, okay? This is the mirror, and this is the tree, okay? This is the building. We have found a way to indirectly measure the tree by using this method.
Because of a physics property about mirrors, these two triangles are similar. You see, because I'm standing straight up, I form a right angle with the ground, and because of the tree is straight, this also forms a right angle. And because of this physics property, these two angles are the same, thus making these two angles the same, making it a similar triangle.
Okay, so Noelle is standing right here, and she stares directly down at this dot on the mirror, okay? And then it reflects, and she moves back until she sees the top of the tree right on the dot.
Because we've proven that these are similar triangles have proportional sides. So we figured, shouldn't the height of this over this equal the height of this over this? So these are the labels that we gave each of one of our points. So technically speaking, px over ep equals xb over fb. Okay, so I'm standing right here. The dot is perfectly on top of the tree. Okay, now I'm going to measure the height of Abhi, and I can also measure the distance and on the seats. I can measure the distance between the mirror and the bottom of the tree. And through ratios, we can find the approximate height of this tree. Abhi and I decided that the top of the tip of this tree is approximately the same height as the very top brick on the top of the school, halfway to that, below the brown top of the school.
Okay, so due to FBX and EPX being similar triangles, we can use these ratios to solve for the tree's height indirectly. So PX, which is right here, is the distance from the mirror to Noelle's feet, which would be 158.2. And we are these are in centimeters, by the way. And the next thing we are looking at is XB, which is the distance from the mirror to the bottom of the tree, the very bottom of the tree, which is 351.1. And the next thing we're looking at is EP, which is the distance from Noelle's eye to the ground, which is 153 centimeters. And the last thing we're looking at is FB, which is, in this case, X, because that's what we're trying to find out. We're trying to measure the height of the tree indirectly. So after you cross multiply these, you would end up with X equals 339.559.
Unfortunately, this was not as close as we hoped. We guessed that the approximate height of the tree was 473 centimeters, but after our math and calculations, we found out that it was really 339.559 centimeters. We believe that our error is caused by simply human error and nature. When we measured this, we could have easily accidentally rounded incorrectly, measured a little off, and all of that could have contributed to this incorrect answer. And also, when we were measuring the approximate height of the tree, it was very windy, so the tree was constantly moving, causing it to be extremely difficult to measure.
Even though the indirect height of the tree varied greatly from the actual direct height of the tree, this does not mean measuring indirectly is always inaccurate.